Hello everybody, today we'll be doing number 140 of 150 and Queens. Alright, so in this particular problem, it's a backtracking problem, and what we're trying to do is find places where we can put the queens where they will not be in contact with each other. To be in contact means to be in the row, same column, and the same diagonal spots, both positive, as in going up this way, or going down this other way. So to let's define that. So if we're doing a backtracking and we're doing this by rows, we can skip the rows, but we still have to remember the columns and the rows that the columns that we have used and the diagonals that we have used. So suppose we're using negatives. We can do row minus column to get zeros all the way down this particular column, diagonal spot. And the same thing of here, we get the 1, the 2, the 1, 1, it goes all the way down. And we have the 2's, and we have the 3. So 3 minus 0, row minus column. This is negative 1, my bad. But I think you get the picture. Let's just make sure that that's the case. This is negative 2, and negative 3, and so on and so forth. But of course, this causes my image to be kind of wacky, to say the least. But it's okay. Well, and you get the same picture here, 1, 2, and 3. What about positives? So if it goes up the other direction, like, what happens? So what happens is, let's erase these, and if we go up from this angle, we have 3, 3, another 3, and another 3. If we add the items, right? So then we have 3 plus 1 is 4, 2 plus 2 is 4, 3 plus 1 is 4, and then we have 5 here, 5, and then we have a total of 6 here. So we can just add them up from row plus column for the positive direction. And with that, we have stored all the possibilities of where it cannot be and where we have to continue and move the die, and where we can add. Once that has been done for a particular row, we just stop, right? If nothing occurs, then we will backtrack, the function will complete, and we will continue on to the next position for the column, and we will keep moving on to test every single possibility. So first things first, we need the columns. Oh wait, sorry. Do we do that? No. Alright, I think we need the results, and we set that to empty. And we need a board because we don't have one right now. And we're gonna set this up board is times n for in n. And that will give us a 2D board. Right, and so we also need our sets so that we can remember where we have been and where we need to go, or we can go. This is positive diagonal, so we're going to do r plus the column, and negative diagonal is going to be r minus the column. Alright, with that, we can define our backtracking with r. And for each, so if our base case is r equals n, that means we have completed, and we need to append. Let's make a copy of the results. Equals join join the result of the row board, and result.append the copy. Okay, with that, we have the results and we return. Otherwise, if C in columns or R minus C in negative diagonals, or R plus C in positive diagonals, then we just continue. Otherwise, let's add everything. Columns dot add C, negative diagonals dot add R minus C, positive diagonals dot add R plus C, and let's set the board at R and C to be equal to Q. With that, we can run the backtracking of R plus 1, and that way we get to the next row. And once we're done, let's remove all the items from this particular column. Let's remove the queen once we're done, and try the next spot. And with that, we're done with this particular column. And yeah, whoops, for C in range, how are we going to get to every column if we don't actually go through it, right? And with that, we're done. So let's run backtracking of the 0th row, and we should have all our results because we would have backtracked all the way down to N and return with the results. Let's see if it works. Maybe there's an error here and there. Let's check it out. All right, there's the error. There should be more errors. Right, so let's see. Calls. All right, very good. Let's submit this answer, and I think we should be good to go. Yeah, so pretty ideal backtracking problem. It was nice to eliminate the possibilities and move forward with the possible possibilities. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.